Welcome to DataBasic, a Warwick Data Science Society podcast aimed at making data science simple and accessible. Today we'll have two guests, Kenneth Lim and Kitty Kovac. Kenneth is part of IBM's data science elite team who implement data science solutions to business problems in various industries, and he'll be talking about his journey from studying business to where he is now, as well as what he would say to people who find themselves in similar situations. Kitty is an undergraduate data science student here at Warwick. We'll be discussing data privacy, where things can go wrong, and a potential solution. Now, Kenneth took an unconventional route to becoming a data scientist. While many come from a technical, mathematical background, Kenneth actively decided to avoid mathematics during his undergraduate degree in international business. It was only when he was writing his honours thesis that he became interested in getting a deeper understanding of the statistics that he was using. He discovered a program at Warwick called the Bridges program, which was specifically made for people in his situation, those who had knowledge of social sciences and business, and who wanted to go into a more technical field. So after signing up for, but then actually not completing his PhD, I wanted to see, did he think that what he gained was worth it? Talk to me about the PhD. So you mentioned that you sort of didn't think about it too much when you were going into it, or you thought about it and it was like, right, this is free, it's education, and it's in a subject that I want to do, and I get a scholarship. Do you think this experience was worth it in a sort of air quotes? Like, how would you define the worth of this PhD? What did it do for you?
I just want to give you a bit of context. So I think I see a lot of people discussing this question around, is a PhD worth it? Is it worth to do a PhD? And sometimes some arguments come up around the cost of things, opportunity cost, as well as and all sorts of things. I'm sure you would know, having done your own research. And to me, when I was thinking of doing a PhD, there were some people who used to tell me things like, this is useless, and and they would tell me, and they would show me, let's say, an article by The Economist, right? I think it's probably The Economist, and if you Google it, you might find it, about the value of a PhD and how worthless it has become because, for example, it's no longer the case that a lot of PhDs stay in academia. And, maybe the skills that you learn are not very transferable and things like that. I did it anyway because, to me, it was not really about the economic benefits at the time. And it was more of a personal thing. I really wanted to learn statistics. And, I always believed that if I wanted to learn anything, I have to go to the masters in it. If I wanted to make a watch, I would go to or if I wanted to make, a very nice shoe, I would have to go to the master cobbler, for example, right? And things like that. And same with statistics. If I wanted to learn about data, it has to be the statistician because that's the bread and butter. And that to me is worth it in itself. And of course now it just so happens that in the industry and society, the role of data has really, increased in its importance. But back then it wasn't that clear, and still I think that the value that I got out of it is something that I cannot replace because the PhD to me was a unique experience. And I know a lot of people, probably have not had such a wonderful experience in a PhD because it can be very challenging, for example, if you can read about it because essentially you're isolated really for a long time, right? And
I think we're all slightly more used to that than usual, given the previous year.
Exactly, and then you double the isolation on top of that. But I was very lucky to be in Warwick Stats department, and I say this really because it really changed my life. I mean, right. The academics are wonderful people, and also the PhD students. It's a really great department, in my opinion. And I learned so much from my peers sitting around me, and they were very generous. I mean, they knew that I was starting off from a different place, but still they would always be ready to help me. right?
Mm.
And at the same time, I had a wonderful supervisor, Jane Hutton, who I don't know. Yes, exactly. She's one. Yes, Jane
She
is.
was actually the last guest we had on the show.
Oh,
She
really?
was just such a fantastic person to talk to because she has such a experience in academia and also applying it in sort of court
The
cases
medical
and medical
world,
statistics and things like
exactly,
that.
in legal. Yeah, so
So,
she was my supervisor, and I have only good things to say about her because,
mm.
you know, I don't know which other statistician would take me on at the time. I didn't even know what a function was when I approached her. Um, and yet she said, okay, you know. And
Wow.
I don't know anyone else. I mean, she is a very unique individual, and she really helped me out so much. She gave me the time that I needed and the space and the encouragement. I I think the value of this is not only from a of course now, as I said, with data being so important in the world now, it's given me a head start, let's say. But at the same time, a lot of it is just the inner confidence, I would say, because when you understand how to solve a problem with data, I mean, that's super transferable, right? And it gives you the confidence to know that if you can achieve something in the PhD, which is you're really breaking new ground in a very tiny way, but still, nonetheless, no one else has done it. And if you could do that, then you could really, to me, it's sort of quite a few of my peers and myself even we've come to the conclusion that we just need time. Like, of course, some problems just cannot be solved, but if you give us enough time, I think we have the confidence and also the experience to know how to solve those problems. And I think that gives increases the chances of us actually succeeding in solving the problem. So that's why I think, to me, it's a wonderful experience, and I would not. Yeah, I think it's super valuable.
Wow, thank you very much. That was a fantastic answer. I'm sure that I mean it's not really a something you hear about so much when you think about PhDs because what's written online and what's written in articles, like you said, the value of a PhD, oh, it's useless. People don't really think about the actual knowledge you get while doing the PhD if you go into it from a knowledge kind of perspective where you think I want to learn about this thing, I want to learn this, or I want to know more about this to see what I actually don't know because I'm coming at it from a perspective where I don't even know what could be there. So yeah,
Absolutely.
people talk about what you get out of it, but they fail to mention the main thing you're supposed to get out of it, which is ostensibly the knowledge.
Correct. And I think also there's another thing, right? And maybe you might be interested in this analogy because I've been thinking about this, a way of trying to, let's say, quantify the value of something. And if we think of this question, we could actually think of it as let's say, a linear model, right?
Right.
Or some kind of generalized linear model, where it's basically an equation, okay? And you have your outcome, and you could call it whatever, value or something. And that is a function of several things, right? And of course, economic benefit or whatever is one thing. Your earning, potential earnings, and things like that. But for different people, that coefficient is going to be very different. And there are other terms in that equation that actually might be a lot more important to another individual. Which, yeah, to me, this is just my initial thoughts on how do I think about these kind of problems, because it's education, it's very important to me, because it really changed my life, right? But for a lot of other people, they might not see it that way, and to me, it's because I don't put my coefficient for the potential earnings or whatever was not that high. It was just more like, I really want to learn, I want to understand these things. That was like, yeah.
Yeah, I think that's a good analogy, and it kind of shows, I guess, from a decision theory or a game theory kind of way, you want to maximize the expected value of something. And of course, a part of the expected value is sort of the raw monetary aspect of it, but also there's other things you get from it, like knowing academics, learning from them, meeting your peers, meeting people who will become the next great people who found companies and all
Exactly, and
that.
my friends are great, and I wonder, why am I not there? But anyway,
Yeah, well, even now, some of the people that I know that have graduated, I look at them on LinkedIn. I'm like, oh, I wonder what they're doing, and then it's like, oh,
oh
fantastic!
wow,
It's
yeah,
good to see that there
exactly.
is really no ceiling to what you can accomplish.
Yeah, and also I think that there's one really nice thing about education, which it really gives you the time to think of some really different ways of approaching problems, right? And I think those skills, if you use them, if you use your time correctly, you are actually gaining a lot of transferable skills, even though it's very difficult to explain to others, right? At times, for example. But I think personally for yourself, it gives you a little bit of the inner confidence and the inner self belief that, hey, you know, when I see a problem, I just don't blank out, or I don't panic. For example, when I see numbers, I don't go, oh my gosh, I can't do it. No, no, it's like, okay, hold on, let me take a step back. Let's approach it and break it down. What is the problem? And then we start to break it down. And I think these things actually help in life as well. That's my opinion.
Yeah, I think that's a very positive outlook to have.
Yeah, and also, the thing we talk about decision theory, also about your utility function. Everyone's utility function is slightly different, right?
Yeah, exactly.
And I think, honestly, if someone would say, look, I want to do a PhD because I can become a data scientist and earn X amount of money, I would say, if that is such a big driver, then, okay. But if that's not such a big driver, spending 4 years of your life trying to solve highly theoretical problems with almost no practical applications most of the time, or at least near-term practical applications, it's going to be difficult. And I would say that you lose a little bit of the value of a PhD from the other perspectives. But if you're doing it for yourself, then I would say, hey, why not?
Yeah, because you don't really need a PhD to become a data scientist.
No, and I think I yeah, you don't, because there are all sorts of jobs that require all sorts of different educational profiles, right?
Right.
And really, a data scientist, you can always. I would say that I've been reading stuff online, and it's not just on data science in general, but it's more of the role of education, formal education, and you see a trend of big companies now saying, hey, we don't need these formal education certificates anymore. You could take a non-traditional route and get into our programs and things like that. So maybe times will change and we go down that road, and then the role of an formal education certificate as a foundation for a data science career might not be that important anymore. So I think it really depends on where do you see the value of your degree, for example, or your education, right? Because again, if you just did something for the outcome of a job and you don't put and okay, let's be practical. Some people have to do it, and I definitely did it with my business degree as well. So there is some element of practicality to it. But at the same time, if you don't put in your heart and soul into the process, then you kind of lose out a little bit, right? So yes, you would get a job, but it's not going to be as fulfilling. And definitely the journey over the years would not be as fulfilling, and definitely would not give you all those skills that you could have acquired if you went into maybe something less quote unquote data sciencey, and put everything inside, right? Because sometimes life, you never know, it just brings you in all sorts of weird directions, and it doesn't mean you did a data science degree means you have to do a data science job after that.
Mm.
That's my opinion anyway.
Yeah, I think it just in general, saying that maybe it's not exactly the degree that you wanted to do, or maybe it's not exactly the one that perfectly aligns with the job prospect. But if there's something else that really you're passionate about, there's a lot of skills that you get from all degrees that you can apply to other ones, like problem solving. Obviously, sort of mathematics, there's a lot of problem solving, but there's different kinds of problem solving in many different degrees. You have to solve problems in a sociology degree. You have to solve problems in a history of art degree. You need to know how to do research. Obviously, there's a certain aspect of technical to it, but I would say that's certainly a flaw rather than and that the floor is not so high. Especially for entry level roles, there's certainly more of a focus on I'm passionate about this. I'm a quick learner, and I can put up with difficult things. I've done this XYZ degree, or even I don't have a degree, but I have put in a lot of work to show that I'm passionate about this and I have the skills to do this.
Absolutely, Martin. And I think there are two things that I would love to add here. And one is, I think if you're passionate about something, and it could be, for example, like you say, I'm in a history of arts, art history degree or a sociology degree, but I end up being, for example, me, suddenly developing an interest in statistics, data science, and stuff. You will always find the way to incorporate those things as part of your learning. Whether or not it's formally recognized or not, you will find a way, right? Now, the second part is, how do you convince someone? How do you convince someone to give you that chance? You see? And you need to do unconventional things. If you take an unconventional route, then everything else has to sort of be unconventional, right? And I think one of the challenges in this world, and it's something that I'm also figuring out, is how do we get beyond just looking at someone's pure background and doing this sort of like box ticking, and if you don't meet this, you're out immediately. And I think it's a very important question because, for example, you would, if you just focused on someone's did they do this degree or not, then you sort of miss those who actually develop those relevant skills. Yeah, perhaps there might not be a lot of people, but they could be very valuable for your organization, as an example.
Let's talk about data privacy. In the wider world, data is being collected for all sorts of reasons, a common one being targeted advertisements. But privacy in data collection and analysis is also relevant in medical experiments or political surveys. People collecting and using this data want to extract meaningful conclusions or predictions from the data without breaking privacy laws. Kitty Kovac will talk to us about a concept called differential privacy. So Kitty, what is differential privacy?
Let's say you have a company and this company wants to gather some data about, for example, about the users of their product. Let's say they want to know how many fingers they have. So they put out a survey, they ask how many fingers each user have, and they'll answer the survey. It's an anonymous survey. Let's say they have Jack, who answers this survey. And the outcome of the survey is that people have 10 fingers, around 10 fingers. And so they learned something about Jack. The company learned that Jack has 10 fingers. Have we violated Jack's privacy in this case? I would say no, we haven't, because if Jack would not have been included in the data set, if he would not have answered the survey, the company still would infer that Jack has 10 fingers. So this is what we call differential privacy, because including Jack in the data set or excluding him from the data set does not make a difference in the outcome of the data analysis. So it's indifferent if Jack is in the data set or not.
What are some ways in which we can deal with issues of privacy in data? Are some better than others?
One instant way that everyone would think about is just removing their names and ID numbers or address or like very personal information by which you can identify them instantly. So you remove them from the data and you'd think, okay, so we kept their privacy. But actually this does not work very well, because in most occasions, it is still possible to relate the data back to individual people. Just to give an example for this, let's think about the Netflix prize. I don't know if you know what that is, but a few years ago, Netflix released a lot of anonymized data, user data. They removed the name, ID, bank details, address, so anything very specific, email address. They removed all that. They released what movies, TV shows people were watching at what time to each user. And the goal of this was to have a competition to improve their algorithms that predicts what a user might watch next. This worked very well for a few years, and then two researchers at the University of Texas managed to link the Netflix data to IMDb data. That is publicly available, the IMDb data, so they did nothing illegal. And they managed to combine the two data just based on three data points, which were a combination of title and the approximate day they watched that movie, because that was recorded on IMDb as well as on Netflix. And based on that, they managed to match up Netflix users with IMDb users. And so by this, they managed to get more information about IMDb users that they should not have gotten, because Netflix data was supposed to be private. And this is an example why anonymizing data does not help. So you can say that, okay, this is just movie data. Who cares if I watched Garfield or another movie or TV show? But actually, it might relate to your political approach, or it could be like done with some other type of data, like health data, which is much more private. So we should look at some other approach. One approach would be to publish statistics only, but that still won't work. For example, if there is only one person from one village that is very specific in that one data set, because you only have one person from that place, you will be able to tell that. Maybe you won't be able to tell everyone, but you will be able to gather some information from the data that you shouldn't have. Another much better approach is to add some noise to the data. So we randomly change up the data to ensure that users are protected. So even if one thinks that based on this data set, there is some private data that they can infer about someone, that person can deny that because it was changed. So that is called plausible deniability. And to give a small example of this, let's say you have an anonymous survey with a question you would not want to answer because it's an embarrassing question. And the way you answer is that you'll have to flip a coin, and you answer truthfully if it comes up heads. Otherwise, if it comes up tails, you'll flip the coin again, and you answer yes to the question if it's heads and no to the question if it's tails. So by this again, you can always blame it on the coin, whatever your answer it is. So this is a way to get people answer surveys truthfully, but this can also be implemented within the data collection. So it's not the person who answers the question or whose data is collected, but after the data is collected, they can change it up in this way, just randomly modifying data, and then they won't be able to certainly tell that that's a true answer for you or that's really your data. So this is a way to ensure that your privacy is protected.
What is IBM's data science elite team? What makes it elite?
I think the way that IBM is thinking about itself right now is it's undergoing a change. It now wants to be very much into the data science space, and they're putting a lot of investments in this space, right? Because traditionally they've been helping the companies. Now they want to help these companies in this day and age with data science. So the IBM Data Science Elite team, as the word elite sometimes has some negative connotations to some people, but I really just think of it as it's almost like I think the way it was created was it was meant to be a bit like an analogy would be a SWAT team, right? Where you would have a challenging situation and you would call a team of experts to come in to solve that situation quickly. And the value comes in, solving that problem quickly. And here, that's exactly what we do. So we get called into projects with different clients to work on all sorts of different projects with them. So we're not, some people might think of us as consultancy, but I think we are slightly different from that. We don't charge, that's the first thing. So there is no revenue from our services. Whereas in a traditional consultancy, this is how you earn your money. we don't charge. It's an investment from IBM to really help companies get two things. One is to familiarize themselves with our platform. We call it Cloud Tech with Data, where you sort of like work on all sorts of data science problems on the platform with calling both, let's say, open source things like Python, R, and also more proprietary things that are software that a company might need, in terms of storing data, managing data, and things like that. So that's one thing. So familiarizing companies with our platform, and the second thing is we do that by working with these clients to solve an important problem that they are facing. So we're working really side by side with these companies, and so it's not really like a consultancy where we go, okay, you should do this. No, we actually work with them and say, hey, if we bring the best of your world and our world, what can we achieve, right? And so there's a lot of collaboration involved. So it's slightly different.
So do you think is the aspect of speed really important for the data science elite thing? Because I guess with traditional consultancy, it's like we get, call the Ghostbusters. They'll work on it for a couple months and they get something back to you. Would you say the data science elite team is more like, we have this situation. Someone quick call the data science elite team, like get the Batman, it's the logo. We have to go to that company.
Yeah, I like that. Thanks. I think speed is one. So there is combination of two things, speed and value. And here we sort of, like you said, some traditional consultancies might take the approach of, okay, tell me the problem. We come in, we consult, we take a couple of months, and we give a presentation. For us, we do that in weeks to 6, 12 weeks, sometimes even 4. It depends on the problem. And so speed is definitely one thing. And during this time, we're actually not only working closely with the clients, but also, there is a lot of they call it the agile methodology, right? Meaning that we are sort of we don't just come in with, this is what we're going to do, full stop. No, we go in, this is what we think we're going to do based on our interactions and, discussions with the other party, and go, okay, this is the reasonable thing that we can accomplish in 6, 12 weeks, 4 weeks, whatever. And this is the plan. But we also know that plans have to be adapted for the situation. And, that's where we sort of have to work around things. And we're very happy to always be, thinking of what the client actually really needs first, rather than saying, no, we have a plan. No, okay, we need to solve the problem first. And therefore, we're a bit more agile, a bit more adaptable to these things. And it's a very iterative process. And the point here, it's not just about, hey, let's build something quick. It's really, this is my interpretation of things, right? It's really the start of something bigger. Because, you can imagine in a company which traditionally hasn't done data science, and there are a lot of companies, right? Because, like I said, the role of data is becoming bigger now. And the issue here is companies need to make investments into projects, right? Because they're investing time and money and resources. So one way of justifying an investment is, you could say, look, it's going to cost whatever amount of money upfront. But sometimes you don't really know the value that it will bring, especially in the data science world, right? Because, for example, with data, it's not just about, I want to see this. No, you kind of, this is what you don't know what you're going to get ahead of time usually, right? It's a bit like a hypothesis testing approach. You can't just say, I'm going to confirm my hypothesis. You test your hypothesis. And, doing some sort of like what we call a proof of concept first sort of helps to give you a rough estimate of what kind of return on investment can you expect. And if the return on investment looks good, you proceed to the next stage, which is, let's now really build this out to be a bit more, to put them into production, or to sort of like infuse that in the company's processes and departments, for example. So
it's kind of like a trial run of what data science can do for a company?
Yeah, you could think of it that way. Exactly. It's sort of like, if you have, it's like, I have a big vision, And then we sort of break it down and say, okay, how are we going to do this? And we
Right.
need to get to that vision using this way. And well, let's do the, like you said, a little trial run, because we know what we need to do. But if we can get a bit of a taster of what it might look
Yeah.
like.
I think a taster is probably a
Exactly.
better way of looking at it,
And
because it's like
then
you get them like, oh, this is, it turns out data science can actually do a lot for our company.
Yeah.
We didn't even think about this, because if you don't know about data science, you don't know what it can do, or you
Yeah.
think you know what it can do, but it turns out it can either not do exactly what you thought, or it can do something completely different that you didn't even realize might be useful.
Absolutely.
How did you find out about this IBM Data Science Elite team, and how did you find IBM as a company when you were looking for positions?
Yeah, actually, it was one of those LinkedIn job postings at the time, and I remember applying for that because I really wanted to be a statistical consultant. So in my last year of the PhD, I actually sort of initiated a mini statistical consultancy with John Fenlon, who teaches design of experiments in Warwick University, the stats department. And we were helping sort of life sciences researchers, and it was very fascinating. Really, I liked it, and I said, I really want a job like this. And so when I saw this job, I was like, hey, I mean, is this it? Like, can this be true? And it turned out to be, hey, wow, yeah. I haven't looked back since, really.
Oh, fantastic. So it was really a case of you're already doing something really similar, and it turns out that this
And I
role
found
exists.
something very similar. Yeah, exactly. I was like, hey,
Yeah.
I want to do that. And I was like, whoa, that thing looks like...
That's
looks like
exactly what I just found.
Yeah,
Hey,
what?
perfect.
I need that, yeah.
So then you sort of went into this role with certain. Did you? Well, let's put it this way. Did you go into this role with certain expectations about what data science consultancy would be like based on what you'd already done, and then was it exactly what you expected, or were there some parts that you that were new to you when you arrived there?
Yeah, and I think I went in with a fresh pair of eyes, because the way that this was positioned was, I kind of understood it was not like traditional consulting, right? It's working with a lot of clients on different projects. There was a slight nuance to it that I was a bit curious about, really. Like, what do we really mean? And it took me a while to understand that nuance. And then the thing that really struck me during this time was that there's a lot of problems out there that data can solve, but at the same time, it's not easy to solve. Sorry, in some sense, right? It's like there are all these problems out there, and sometimes it's very clear how data can solve it, and sometimes it's not. And also, the one thing that was kind of sort of it really made me, it helped me understand the world a bit better, was when I realized it's not all just about applying models, or in the world of machine learning, algorithms, for example. That's just part of the process. And I'm quite heartened because, when I worked with John Fenlon, or even with Jane Hutton, a lot of the time it's spent trying to understand and define and refine what is the question, what are we trying to solve here. And that, to me, was something that I really enjoyed then, and thankfully it helped that in this job that there's a lot of that going on, and it's always nice that it's a different domain after a while and things like that, so you get a very broad exposure.
So could you give us sort of an example of the kind of things that you've been working on at IBM?
Yeah, so it could be, for example, recently, I worked with a very large public transport company based in the wider region in Europe, Middle East, and Africa. And what we were trying to do was to help them and work with them to create personalized marketing campaigns for their own customers. in a semi-automated way. So really trying to build a semi-intelligent system where you could automate certain processes that would help you,
Right.
and then eventually sort of like gives you the relevant insights that you need. Let's say the marketing person needs to create the campaigns that they want to do, right?
Okay.
And what we ended up doing was, sort of customer segmentation, and it was the process of it was really interesting, because in the end we managed to find some really nice insights about these customers that otherwise they would not have found. And there was a combination of doing what we would call traditional business intelligence dashboarding, but also sort of infusing that with more advanced data science methods to really understand the data much deeper than what traditionally would have been possible. And we ended up finding a very small cluster of customers that was really high value, and that otherwise would not have been found in these. And you could imagine this, if you have tens of millions of customers, how do you find, a group of small individuals that are actually, kind of hidden, but they're very valuable, not necessarily in the traditional sense of customer spending only, but in other dimensions, And you could think about this as a huge space. Like you could be wading through this and not finding them because there's so many data points, right? Mm-hmm. And so this is, I think, one example. Another example is working with insurers to sort of help them process the claims a bit better, insurance claims, and building again some nice machine learning algorithms to help them predict certain outcomes and things like that. So really we could be doing a bunch of different things. But hopefully that gives you a bit of a flavor.
Yeah, I think given the broad overview and now some specific examples, it's a nice taste of what the data science elite team at IBM does. So what would you say is the role of mathematics in either data science or the work you're doing now?
Yeah, no, that's a great question, Martin. And I think, to me, again, if we go back to that analogy of your equation, and you substitute your outcome now, and you for whatever outcome else, and you put mathematics as an ability, for example, it's a continuous measure or things like that. It's a score even. And I would say that really depends, the coefficient of that term really depends on the kind of job that you're in, right? And I would say that as a base, there is a level that you need, but for a lot of jobs, I think the ability to apply the mathematics is a lot more important than deriving something. That's number one. And the other thing that I think doesn't get talked about a lot, but this is my own personal view, is mathematical thinking. There is a certain approach that you learn to solve problems when you study mathematics. And it's a bit more on the logical side of things, how do you break down problems and things like that. Mm-hmm. And I think that, to me, is probably one of the most important things when you go out into the working world, really, especially with doing a data science role, right? Because in if we think about somewhere like DeepMind, for example, I think that comes the closest to me. For example, it comes the closest to an academic outlet in the business world, right? And I think there you probably, if you're working on developing novel algorithms, novel models for all sorts of problems, yes, I think you need a high level of mathematics, because you would probably be proving a lot of things, and it's basically almost like academia, right? But on the other hand, if you're applying existing methods, then that changes things. It's no longer about deriving but applying. So you really need to know how to define a problem, which I think mathematics trains you very well to do, right? You need to always have what is the problem, and then you start to break it down, and then you start to develop your steps. And I think it works this way too. And then finally, you need to be able to, when you apply it, you need to be able to read a bit of maths, right? So, for example, you might be thinking of, hey, I'm not sure what this model algorithm does. Let me read up about it. And then you start to see some equations. Now, you could either get turned off by it and then, or you could say, hey, I'm going to apply my mathematical thinking here and my knowledge. Go, oh, okay, this is roughly what it does. So I think here, if the concept around application, then it's more important to be able to apply your mathematics, and the thinking that comes with it is going to be the main plus point here.
So it's more about how mathematics trains you to think specifically than the things it teaches you, or like the specific techniques that it teaches you when you're in a more business or even data science realm. I guess there's a continuum
exactly
from like Google DeepMind to maybe on a more business intelligence or IBM Data Elite kind of thing.
Yeah, exactly. So I think it really depends on the spectrum, right? Like I said. So if you're creating new and novel algorithms, of course, you would need to apply more of the theoretical side of things. But if you're applying stuff, then it's really about how can you use what you already know to even if you need to learn something, it's basically using your knowledge of maths, reading symbols, understanding equations, and going, okay.
And as a final question, what tips would you have to anyone trying to get into data science? So I guess specifically from someone with a similar background to you, or someone who hasn't done data science so much before.
There's a technical side of things, right? There's the data science side of things, and there's the non-data science. To me, the data science side of things, I was trained by Jane Hutton, who taught me really the importance of exploratory data analysis. And I recommend everyone starting with exploratory data analysis. I used to tell Jane, but this is so simple. She's like, okay, show me. And I couldn't. I was like, well, I don't understand why. Everyone says it's simple, why can't I do it? She said, maybe it's not so simple after all. And I was like, but it's just graphs. It's just tables. What do you mean? I don't believe it. And then I came to believe that no, actually, good exploratory data analysis is not easy to do, but it's the foundations for any applied work, because you really need to understand your data. Even though nowadays you can run any algorithm, but if it doesn't make sense, it's not going to cut it. You need to understand your data. You start with exploratory data analysis, and then I would say, learn data visualization. How do you communicate these kind of things? Because that's part of exploratory data analysis, but it's a bit different because now, when you do exploratory data analysis, it's sort of your own thinking of things, right? You might do several box plots and things like that, but at the end of the day, how do you communicate this to someone else? How do you make it crystal clear? What's the main message they're trying to create? Once you do those things, and at the same time start learning, applied statistics on the other side. So, for example, applied statistics, I think there are two elements. One is you could take a good book like a book in medical statistics by Doug Altman. I think it's called, Practical Statistics for Medical Research. Okay, take that kind of book. It gives you a very good overview of all the different methods, starting from exploratory data analysis to ANOVAs and things like that. It gives you a very good grounding. And at the same time, I would suggest someone also studying a little bit of mathematics. It never hurts. You need to understand and not be afraid of numbers and things like that, right? And I think once you do those things, you have a good grounding. So a lot of people might say, go Kaggle, do machine learning. I take the view, start with your basics, because I learned it from my own experience. Having the roof is not going to be enough. You need the foundations. And to me, the foundations come in three things: exploratory data analysis, mathematics, some level of mathematics. I think you need to understand functions and calculus and some things like that, but not the full-blown,
right. So don't sign up for a maths degree just because you want to
exactly.
do data science.
Especially if you don't already have one, you're going to set yourself up for some disappointing results, I would say, if you're not in it for many, many, many years. So there is the exploratory data analysis, mathematics, and also, a practical book on statistics, applied statistics. That will set you up very well. And the last one is the non-technical side of things. I would say there are two main things. One, it's perseverance, and the other one, it's being unconventional in your approach. You can't compete with people who have all the prerequisites in the same way. You have to think of unconventional ways to put yourself out there. And when you do that, you're going to get a lot of rejections. Trust me, I've put myself out there because I know. And that's why I know. You're going to get a lot of rejections, and you got to take them on your chin. And you got to believe that and you got to believe that you're going to get it, and you got to keep working. Because even though you get rejected, you're one step closer, because it just takes one person to say yes, But at the same time, you need to be open to feedback that say that, oh, actually, I don't have those things. I kind of need to learn it, But then also balance that with like, hey, you can't learn everything, right? And like, what's the point of learning the latest and greatest algorithm if you don't even understand how to plot your data? Or if you don't even understand what a linear regression is? And people think linear regression is so simple. I would say, well, there's a lot to it, and it's a bit more, if you really dig deep into it, there could be very, very interesting results and things that you might not have expected. But anyway, those are my points. So just to summarize, applied mathematics, a bit of mathematics, exploratory data analysis, a good applied statistics textbook. I personally recommend, Practical Statistics for Medical Research by Doug Altman. If you Google it, you get it. And then Perseverance and Creativity.
Thank you to Kenneth and Kitty for joining us today, and thank you for listening. Next time on DataBasic, we'll be joined by Dr. Becky Arnold, an astrophysics researcher at Kiel University. We'll talk about the Turing Institute's Guide for Reproducible, Ethical, Inclusive and Collaborative Data Science, to which she was a contributor. We'll see you next time.